Hey class, I will be going over skeletal muscle contraction. So for a muscle to contract, we need a certain, nerve stimulus. So we've got the motor neuron here that comes from the central nervous system, and I've got a picture of a muscle fiber here. So when these two interact, this would be called a motor unit. Each muscle fiber contains many myofibrils, excuse my drawing, and each myofibril contains thick and thin myofilaments. So here I've got a diagram or a little model here of a sarcomere. So in red, we've got the thin filaments, which is called actin. In blue, we've got the thicker myofilament called myosin. So we've got the M line here in the middle, and the H band is the space between the thin filaments. So sarcomere is from H line to H line, and when the H lines come closer to each other, that is a contraction. So we're wondering, well, how does this contraction start? Like I mentioned, excitation. So we'll start here. A nerve impulse will go down to the synaptic knob. We've got the synaptic knob here in orange. It contains mitochondria. As we know, mitochondria produces ATP for energy. And the synaptic knob also has synaptic vesicles. In these vesicles, we've got what is called acetylcholine. So then, when calcium is released into the synaptic knob, that will trigger the synaptic vesicles to release the acetylcholine into the synaptic cleft. The synaptic cleft here would be the space between the synaptic knob and, in the green here, the sarcolemma. So acetylcholine in the synaptic cleft will then want to bind to a receptor in the sarcolemma. So the receptor here initially closed, and then when binded with acetylcholine, will then open. So acetylcholine is released, it binds to the receptors, the sodium, that opens the sodium ion channels, leading to an action potential that will go in all sorts of directions here in the sarcolemma. So then we can start excitation, contraction, coupling. So the electrical signal travels here, the action potential travels from the sarcolemma down the T-tubules to the sarcoplasmic reticulum. The sarcoplasmic reticulum will then release calcium here, and essentially the calcium will want to bind to the thin filament. So I've got thin filament here, actin in green. The thin filament has tropomyosin in orange, and the tropomyosin has troponin. So when the calcium is released from the sarcoplasmic reticulum, it will then bind to troponin, and that will cause the tropomyosin to then shift. Let's see if I could do this here. There we go. Exposing the active site. So the active site would be here in red, and then we can start the contraction process. So down here I've got the thicker filament here, which is myosin, and this is a myosin head, which contains ATP. So then ATP will then hydrolyze into ATPase. Let me attach the inorganic phosphate here with ADP. Excuse me as I am doing this with one hand. So, anywho, the myosin head will then contain the ATPase, and now it is ready to attach to the active site. So it would attach to the active site there, and tape this here, which will then do what is called a power stroke. So then the myosin head will pull the smaller filament here towards the M line, which is the center of the sarcomere. It will pull it this direction, and then ATP will come along here, and this will cause the cross bridge to then release. So then the myofilament, the thicker myofilament here, myosin, will then release once ATP is exposed to the myosin head again. So this process will just repeat itself over and over, where ATP will then hydrolyze. We've got ATPase again here. This will cause this to, for the myosin head to once again attach to it, pull the thinner filament to closer to the M line. And this will just continue over and over again until the sarcomere shortens completely. Then we can start relaxation. So then for the muscle to relax, the nerve impulse stop. So this nerve impulse will then stop. The symptomatic cleft here that contains the acetylcholine will be, basically the acetylcholine here will be released or broken down, by ACHE. Then the active transport from the this calcium here will go back to the sarcoplasmic reticulum. So then of course calcium will then release itself from troponin, no longer connected to troponin. And then what happens is the active sites will then close. So then myosin here will no longer be able to bind with the thinner filament with actin, therefore causing this to just relax. That would cause the myofilament, to go back to its original position, and the sarcomere returns to original position. So over here we've got the sarcomere contracted, Z lines moving farther from each other is what it will look like when it relaxes. I hope you guys liked my video. I know it was a little lengthy, excuse all the shaking and everything, had to do it with one hand. You guys have a great weekend. Thanks for watching.